Welcome to Network Playroom. So we've already looked at PGP peerings and configured both internal and external PGP in different ways, but we haven't advertised any networks in PGP yet, and that's what we'll cover in this video today. So we'll go over some theory as we work on the lab, and we'll continue with the same topology that I've used in my previous videos. So this is a really simple 3-router topology with R1, R2, and R3. I've already made some configurations previously, so we don't have to set up the PGP peerings from start. So R1 and R2 are configured as ePGP peers using their loopback interfaces, and a similar configuration is also applied on R2 and R3, so they also form an ePGP neighbor relationship. We'll probably not do any configuration on R3 in this lab, so we'll focus on R1 and R2. Other configuration that I already have applied is EIGRP is running between all of these routers, just so I can have reachability between the routers and BGP peerings can form. But again, as I mentioned in my previous video, this is not a realistic configuration. You would not see this kind of configuration in a ISP environments. But it'll do for the purposes of this video. So let's get started. Let's play. Now first, a little bit of theory actually. So let me just go ahead and jump on the terminal. So let's go on R1. So I'll just briefly show you what I have configured here. So this is the PGP configuration. Except that it's not showing me anything. Oh, it was just had a slight delay there. So nothing super special here. As I mentioned, the ePGP peering is configured using the loopback interfaces. And if we look at the show IP PGP summary command, so you can see that the neighborship is up, but here, like, no prefixes have been advertised yet. So we're gonna look at that shortly. But first, let's talk about the theory a little bit. Now, the PGP topology table holds the network layer reachability information. So we want to know how we can inject routing information in the PGP table. Now, there are a couple of ways to do this, and we'll discuss the PGP network command and route redistribution. Now, similar to IGPs, PGP can use the network command to insert routes into PGP. However, the PGP network command works differently from IGPs. And by the way, for the purposes of this video and this discussion, we'll assume that the no auto summary command is configured. Now, with the PGP network command, the router performs a routing table check to verify if the route is in the current IP routing table. And if the exact route exists in the IP routing table, then the equivalent NLRI is also put in the local PGP table. And note that this has to be an exact match. So let's take a look at what other information we can find here. So first, let's look at the interfaces I have configured. So I have a few loopback interfaces here that we're gonna use. So we'll advertise these two networks via PGP. By the way, I have excluded those from the EIGRP configuration. I can actually show you that briefly as well. Router EIGRP. So you can see here that I've enabled EIGRP on the interface linking to R2, and then on this loopback interface. And then let's look at the show IP routing table. I mean show IP route, not show IP routing table. All right. So now we can see that those networks are listed in the IP routing table, which is a requirement to be advertised into BGP. So let's do that. Let's first advertise this network, the 11.11.11.11. So we'll go into the BGP configuration mode, and then we'll type network 11.11.11.11, and then the command syntax is network and then the network number followed by mask and then the subnet mask. Note that you can also leave this part out, but then the command assumes a classful network mask, which in this case we don't have because I've used a /32. So like this. And now PGP should advertise this network. And actually it could take a while. We might have to refresh the peering. And actually we don't, because it's right here. So you can see that the network is advertised right here. All right. And let me actually prove what I said before, that this is not going to work unless you use the correct mask. So let's try the other network, but we'll purposely apply a wrong mask in the command. So let's do a /24, for example. So let's say that we mistyped the command. Okay, it's already giving us an error. Let's see if we can get rid of that. Okay, there you go. Now it's a valid command. So the reason I moved the last .111 part is because I wanted to write the network address. So now you see that this command was applied. But if we go back to the packet capture, we should not see any new networks here. And even if we do a refresh, so let's try that as well, clear IP PGP. Well, we can even do a hard reset. Okay. Let's do it this way. So let's reestablish the neighborship. Okay, and then let's go back to the packet capture. Right. Okay, here we go. It took a while to send the update message, but now we can see the 11 network here, but not the 111. Okay. So let's go back to the terminal. And then router PGP 65001. And we'll remove that command, this one. And let's advertise that network with the correct command. And you should see something interesting here. There we go. now it should advertise this new network. So let's go back to the Wireshark capture. All right, let's open up the PGP packet. So as you can see right here. Okay, I'm gonna go back to the command line again. And I'm gonna do another hard reset, and then we'll wait for the updates to show up again because I want to show you something interesting. So let's do the clear IP PGP star again. By the way, you should never run this command in a production environment. This is what some folks call the career ending event or the career ending command, because that completely destroys all your PGP peerings and your network will be down for a considerable amount of time. So don't run this command. Okay, so we've done the hard reset now, so let's go back to the Wireshark capture and wait for another update message. This is not it, so let's give it a few moments. All right, here we go. Now we're seeing some new update messages right here. So let me click on this. Now, this is the interesting part that I wanted to show you. So if you look here at this network layer reachability information part, technically PGP does not advertise routes. And it may sound funny when I say that, but what I mean is that actually PGP advertises the path attributes and prefixes that share those same path attributes. So it's a little bit backwards from what we're used to in IGPs. Routing protocols like EIGRP or OSPF, they advertise those routes individually and then they attach the metric to that route. So it's kind of one-to-one correlation. One route, one metric. Whereas in PGP, you have a list of the path attributes and then you slap the routes in the same packet that share those path attributes, if that makes sense. So we could technically have many more routes attached to this one update message, as long as they share these common path attributes. Now this is very efficient because imagine you have tens, hundreds, or thousands of routes that all share the same path attributes. You can just keep adding them to this update message, up to the maximum size, of course. Then you might have to break it down to multiple update messages. But the concept is very efficient. So next, let's talk about route redistribution and actually advertise a static route into PGP. That way, we'll accomplish two things. You'll see how route redistribution is configured, and you'll also see that the route is advertised in another update message because the path attributes will not be the same. For example, the origin path attribute is going to be different because we're not using the network command to advertise the network, but we're using redistribution. And actually this is a little bit misleading here because it says IGP. Like, what does that mean? But it means the network command. I believe why they are referring to it as IGP is because the route has to be present in the IP routing table before it can be injected into PGP. So technically you have to internally know about the route before you can advertise it into PGP. Anyways, let's get started with route redistribution. So let me go back to R1. And actually, I didn't even show you any verification commands right here. So if we look at the show IP PGP summary right here, so this will show you that the PGP peering between R1 and R2 is up. And this is still showing 0 because we have not received any routes from R2. We've only advertised routes to R2. So actually, if we jump on R2, show IP PGP summary, you can see that 2 prefixes have been received from R1. And another way we can look at that is show IP PGP. So we can see the routes that have been received right here. I will not break down the show command output in this video. This can get quite elaborate as well. But a few important things to note here is that the asterisk sign here, it means that the route is valid. So for example, there are some cases when the next hop is not reachable. And in that situation, PGP does not consider that route valid, and it cannot be installed into the routing table or used for packet forwarding. And then this greater than sign right here means that the route is the best. So if you learn the same route from multiple different neighbors, they would be listed under here as well. But the one marked with the greater than sign is the best route, and that's the one that would be used for forwarding packets. And then another thing is this little I here, which is actually the origin code. So this part right here, it can be either I for IGP, E for EGP. You should never see this. This is obsolete. EGP is the predecessor of PGP and is no longer used. And question mark refers to incomplete, which actually means redistribution. So when we go into the next step and configure route redistribution, you should see the question mark right here. And this part here is the AS path. So this lists the autonomous system numbers that the packet has gone through, or the update has gone through. Okay, so let me go back here. Show IP PGP. This gives us almost the same information. One difference here is that the AS path attribute is empty. So there's no AS path numbers currently because this route is locally originated. The same with the next hop. Next hop is 0000. Okay, now, so let's go and figure route redistribution. So we'll first need to set up a static route. So we'll use the documentation IP addresses to create a bogus network, and we'll attach it to the null 0 interface. So let's do IP route 198.51.100.0, and it's a /24 network, and null 0, just like that. And now let's look at our IP routing table. Again, I want to write show IP routing table, show IP route. Here we go. So you can see the route right here. Now let's go to the PGP configuration. And we'll do redistribute static. Like so. And let's see here, show IP PGP. You can see that the route was added here. And now let's go to the Wireshark packet capture. So we can see here that the route is advertised. let me close this for a second. So this is the network layer reachability information. This is the bogus network that we added. And here are the path attributes. So as I mentioned before, you can see that this part is different. And right here as well. So you can see that it's marked with a question mark, and this one is I. So let's go to R2, show IP BGP. So that route was learned by R2, and it is also in the routing table. Now, let me do a reset of the PGP peers again, so you'll see that those are actually two different update messages. Clear IP PGP star. Okay, and then we jump to the packet capture. We might have to wait for a little bit again, but we should see two separate update messages. So one with the 11 network and one with the 111 network. So let's give it a few moments. Okay, now we're seeing some activity here. So let's look at this packet. Okay, let's close these up a little bit so we can make sense of this. Let me move this up slightly. All right, so right here. So you can see that we actually have separate packets here, separate update messages wrapped in this one packet. Let's close this part. So you can see that these are actually two different PGP update messages. Let me see if I can open it up a little more. All right, so right here, you can see those two networks that I mentioned, 11.11.11.11/32, 111, 111, and so on /32. And those two networks, they share these same path attributes. Okay, let's close these up a little bit. And now here's the other PGP update message. So this is the one for the 198.51.100.0/24 network. And you can see that the path attributes are different. Well, technically only the origin code is different. When you advertise routes together, they must share all of these path attributes. So you can't start mixing them so that you only include these three path attributes that are same for all of these routes and then do some weird tricks with the origin codes. That's not how it works. Basically, you put together the path attributes and then you define what networks share those path attributes, and then you can advertise them in the same update message. So I hope that has been clear from this video, because PGP handles routes a little differently from IGPs. And actually, one other thing, if you remember from redistributing routes with IGPs like EIGRP or OSPF, a seed metric or default metric is required for the redistribution to work. Now, because the decision process is different for PGP and it does not use metrics like IGPs, then you don't need to worry about the seed metric. So as you saw when we configured the redistribution, I did not define a seed metric. I simply redistributed the static route into BGP, and that was it. In IGPs, you need the seed metric because, for example, if you are redistributing EIGRP routes into OSPF, OSPF does not understand the EIGRP metric. and it needs some kind of value for the route. A metric has to be assigned to the route. Otherwise, how can the routing process use that route? So just keep in mind that there is this difference between BGP and IGP in terms of route redistribution. So I hope you found this video helpful. If you have any questions, let me know in the comments. Thank you for watching, and I'll see you in the next video.